Hello, welcome back. We are talking about Chapter 4, Proportional Relationships, and today we are starting Lesson 4, Similar Figures and Proportions. So, figures that have the same shape but are not the same size are called similar figures. So they have the same shape but not the same size. Those are called similar figures. In similar figures, the ratio, and remember when we see the word ratio, we're talking about a fraction. So in similar figures, the ratio of the lengths of the corresponding sides are proportional. Now, when it says the lengths of the corresponding sides, that is a new kind of term. And basically, what corresponding sides means is that, let's look at these triangles right here. If you see on these triangles, they have a small side, they have a big side, and they have a middle side. So the sides that would be corresponding on this triangle, the smallest number would be 6. So that would be the smallest side. That would correspond with the smallest side on this triangle. The smallest number is 9. So that means these two sides of the triangle would be considered corresponding. Okay? So that would be right here. This side and this side. Those are corresponding. Now, what would be the biggest side? Well, the biggest side in this triangle would be 10. And the biggest side in this triangle would correspond with the biggest side in this triangle, which would be 15. So those sides would be corresponding. And then lastly, you have the side that's in the middle, which would be 8 here. And so that would correspond with the side that's in the middle of the smallest and the biggest, which would be right here for 12. So these two would be corresponding sides. So now that you understand what corresponding sides are, it says in similar figures, remember those are figures that have the same shape. So you see how these kind of have the same shape, but they're not the same size. This one's obviously smaller and this one's bigger. I kind of think about it, if you take a triangle and then you put it on a copy machine and you blew it up, you made it really big, or you shrunk it down, those would be examples of things that would be similar. So they have the same shape, but not necessarily the same size. Those are similar figures. So in similar figures, the ratio of the lengths of the corresponding sides are proportional. And the corresponding angles have equal measure. So let's go ahead and determine if triangle ABC is similar to triangle XYZ. So we can write a proportion for each pair of corresponding sides. So the first thing we're going to do is we're going to look at the longest side. And the longest side is the pink side here. So we're going to take AB right here. That's how you state this side, AB, over XY, which is 15. AB is 15, so that goes here. Over 10, that's what XY goes, so that goes there. And then you just reduce it, okay? So with those, we know that 15 and 5 both have a common factor of 5. 5 goes into 15 3 times, that's why that's 3. And 5 goes into 10 2 times. So that right there is our, this is our ratio right here. 3 over 2, okay? So let's go ahead and do the middle sides. So the middle sides, we highlighted in yellow. So we have BC, and we want to keep, so right here when we started, we took the big triangle over the little triangle, so we want to keep that consistent. So the middle sides, we're going to start with the big triangle on top and the smaller triangle on the bottom. So BC right here is going to be over YZ here. So we're going to have 12 over, YZ, over 8. Okay, and then we're just going to reduce that. So is there a common factor between 12 and 8? Yes, there is. It's 4. 4 goes into 12 3 times, and 4 goes into 8 2 times. And if you notice, the ratio here is also 3 over 2. Okay, so we have 3 over 2 here, 3 over 2 there. Okay, so let's do the shortest side. The shortest side of the big triangle is AC over the small triangle is XZ. Okay, so for AC, the side length is 9 feet. And the side length for XZ is actually 6 feet. So we're going to go ahead and reduce that. And when we reduce that, we're looking to see if there's any common factors. And yes, 3 goes into both 9 and 6. 3 goes into 9 3 times, and 3 goes into 6 2 times. So there again, we have the same thing right here, 3 over 2. So that shows that they're all the same. If they're all the same, that means that they are proportional. So the corresponding sides are always in the ratio of 3 over 2. That is the ratio of the corresponding sides, and it's the same. So that means that the triangles are similar. So if you have the same ratio for all of the corresponding sides, the same for the longest sides, the same for the middle sides, the same for the shortest sides, it's the same number, that means that the triangles are similar. So if a polygon has more than 3 sides, you must also show that the corresponding angles are equal as well. So let's go ahead and look at a few problems. So let's look at number 1. It says identify the corresponding sides, use ratios to determine whether the figures are similar. Okay, so let's start here with the biggest side. The biggest side. So the biggest side for this big triangle is going to be, we got 10, 12, 16. The biggest side is UT. So we're going to have UT over the biggest side of the small triangle, 4, 6, 8, which is 8, which is EF. So UT over EF, and that's how you state that line segment, UT, and this one you call EF, equals, then you put the numbers in. UT is the same thing, the distance of that is 16. And the distance of EF is 8. Okay? And we want to try to reduce this because we can simplify this. So what number goes into both of those? Well, I know that 2 goes into both of them. I know that 4 goes in, but the biggest number that goes into both of these would be 8. 8 goes into 16 2 times, and 8 goes into 8 1 time. So that means the ratio is 2 over 1. Okay? Now, let's go ahead and talk about the middle side. Okay, so we're going to be talking about the number in the middle. So when I'm looking at these, I know that 10 is the smallest, so that means that right here, SU would be the middle side. So we're going to have the big triangle over the little one so it stays consistent. So SU over the middle side over here, 4 is the smallest, which means DF would be the middle one. Okay, now we're just going to fill in the numbers. So SU is equal to 12 over DF is equal to 6. And then we're just going to simplify this. I know that 12 divided by 6 is actually equal to 2, right? Or you can think about it, 6 goes into both. 6 goes into 12 2 times, and 6 goes into 6 1 time. So you end up with 2 over 1. Okay, which is the ratio, and so far they're the same. Okay, Now let's do the last one, the smallest side. Okay, so the smallest side here, or the shortest side, would be ST over the shortest side here would be DE. And then we just fill in the numbers. ST is 10 over DE is 4. Okay, so then we're just going to reduce them. Do they have a common factor? Yes, they do. 2 goes into both of those. 2 goes into 10 5 times, and 2 goes into 4 2 times. So this ends up being 5 over 2. Well, let's look at this. What I see is that 2 over 1, this is the same ratio as here, but this ratio is different. So what that means is that the triangles, I'm going to use that word for, see, it's like a triangle with comma. Triangles are not similar. For them to be similar, every single one of these ratios has to be the same. And this ratio is 5 over 2, so it's not the same, so they're not similar. Okay? So that's example 1. Let's go ahead and look at example 2. I'm going to draw a line here. Okay? So, example 2, we're going to kind of do the same thing. So we're going to start off with the biggest side. I'll just say biggest, which is, if we're looking here, the biggest side, 5472, is going to be this one right here. So JL. JL, we're going to go with JL over the biggest side here, which is 24, which is XZ. Sorry, using the symbols here. XZ. Now we're going to fill in the numbers. JL is the same thing as 72. And XZ is the same thing as 24. Okay, perfect. So now we're just going to reduce this. If I look at this, I know that that 12 goes into both of these. I'm pretty sure that 12 goes into 72 6 times, but I'm just going to go ahead and do that math to double check. So I'm going to go 12 times 6 and figure out what that is. 6 times 2 is 12. Write the 2, carry the 1. 6 times 1 is 6, plus 1 is 7. So yeah, it is 72. So 12 goes into 72 6 times, and 12 goes into 24 2 times. And 2 also goes into both of these numbers. So 2 goes into 2 1 time, and 2 goes into 6 3 times. So the ratio here is 3 over 1, or just 3. Okay? So that's the biggest side. That's the ratio for the biggest side. Now let's talk about the middle side. Just the middle one. Okay, so the side that's in the middle would be the number that's in the middle, which is right here. That is JK. And we're doing the big triangle over the little one. So JK over the middle number here is 18, which is XY. So JK is 54 over XY, which is 54, and XY is 18. Okay, so we need to reduce this. When I look at these two numbers, 54 and 18, I'm looking for a common factor, and I'm pretty sure that 9 goes into both of these. 9 goes into 54 6 times, and 9 goes into 18 2 times. And I can still simplify this. 6 and 2, 2 goes into both of those. 2 goes into 6 3 times, and 2 goes into 2 1 time. So there we have our ratio, 3 over 1, which is the same as the biggest side. So those are the same, which is great. So now we just have to try one more. We have to try the smallest side, or the shortest side. I'll call it the shortest. Okay, so the shortest side on the big triangle, we're keeping the big triangle on top, would be right here, KL. So it's KL over the shortest side here, which is YZ. And then we just fill in the numbers. So KL, the side for KL is 36. And then the side for YZ would be 12. So 36 over 12. Well, when I look at this, I know that 12 goes into both of these numbers. 12 goes into 36 3 times, and 12 goes into 12 1 time. So there we have it. We have our ratio, which is 3 over 1, which is the same. They're all the same. So that means that these two triangles are similar. So we can say the triangles are similar. Okay? And then we can add a little woohoo for good measure. Awesome. Okay, so let's go ahead and turn the page and look at a couple other examples. I don't know why this is. So this is supposed to be 3. 3 here. Make that a 3 on your paper. Thank you very much. So 3 and 4. Okay, so let's just go ahead and try 3 together. So let's see here. Let's start with the biggest side. So the biggest, and I'm going to start with this triangle and go to that triangle. So the biggest side, when I'm looking at 16, 20, and 24, would be this one right here. And we're going to call that PR. So it's going to be PR over the biggest side over here, which out of 12, 15, 18, which would be FH. So once we have the symbols written down for those side links, we're going to go ahead and fill in the numbers. So PR is 24, so it's going to be 24 over 18. FH is 18. Okay, then we're just going to simplify these. So is there a common factor between those? The 24 and 18? I'm going to say yes. I'm going to say 6 goes into both of those. 6 goes into 24 4 times. 6 goes into 18 3 times. And that's really simplified. So our ratio is 4/3. Okay, perfect. Let's go on to the middle side. So the middle side, for the big triangle, which is going to go on top, is going to be, the middle number is 20. So that side is QR. So it's going to be QR over the middle side over here, which is GH. And that is equal to, we're going to put in the numbers, so it's going to be 20 over GH is 15. And then we just need to reduce it. Is there a common factor between 20 and 15? I would say yes. There's a common factor of 5. 5 goes into 20 4 times, and 5 goes into 15 3 times. So that ends up being 4/3. Hey, and those are the same. So far, things are looking good. Now we just need to look at the shortest side. So the shortest side in the big triangle, which goes on top, would be PQ. So we're going to have PQ here over the shortest side of the smaller triangle, which is right there, which is FG. Okay, now it's time to fill in the numbers. So PQ is equal to 16 yards. So I just put 16 there. Over FG is 12. So I have 16 over 12, and I just need to go ahead and reduce that. Is there a common factor that goes into 16 and 12? The answer would be yes. 4 goes into 16 and also goes into 12. So 4 goes into 16 4 times, and 4 goes into 12 3 times. So our ratio is 4/3. And look there, it is the same. So they're all the same. That means that the triangles are similar. All right, great. Okay, so let's look at number 4. Now, number 4 is a quadrilateral. There's 4 sides here and there's 4 sides there. Okay, I want to go back and I want to refer to my definition of what a similar figure is. It says figures that have the same shape but not the same size are similar figures. And if you look here at these triangles, they have the same shape, but they don't have the same size. And when we looked at their ratios here, their ratios were all the same, which means they are similar. But let's look at these. Do these quadrilaterals, 4-sided figures, have the same shape? And the answer is no, they do not have the same shape. This, all the sides are 13, and it's a square. But this, all the sides are 13, but it's a rhombus. And the reason why it doesn't have the same shape is because the angle measures are different. So this is not similar. We can just tell by looking at it because it does not have the same shape. So we can say the figure are not similar. And then there we go. So if you're doing these and you see that they're not the same shape, you really don't even need to go any further. You can just say, boom, they're not similar because they're not even the same shape. To be similar, they have to have the same shape, but they just have different sizes of that shape, which means they have the same ratio when you look at all the corresponding sides like this one right here. So great. All right. We will see you next time.